In a survey of 221 people, 167 agreed. Determine a 95% confidence interval for the population proportion. First thing we had to do is find the population proportion, or the likelihood of this happening. All right? So what we get here is that would be 167 out of 221. That's the likelihood. When we divide that out, we get approximately 0.76, which is a 76%. All right. Next, what we have to do is we have to think which one of these to find the margin of error. Well, since this is a sample proportion, we're going to use this one with the P. All right. So what we're going to do here is we are going to find E. We are going to look at our z-score. Our z-score comes from these. Okay, it's 95% confidence, so I want 1.96. So we got 1.96 is my z. All right. Then I have a square root, so a big square root with a fraction inside. Next, I have these two pieces. So I need the sample proportion, which is 0.76, and 1 minus the sample proportion. All right. So that would be 0.76 times 1 minus 0.76. All right. And then we divide by n, the sample size, which is 221. All right. Now, when we crunch this particular thing, we will get, what do we get here? We get about 0.06. So what that means now is this is our likelihood, and this is our adjustment. So we're going to add or subtract this from this. So when we add or subtract it, our answer would be, well, if we take 0.76 minus 0.06, we will get 0.70. That's your low. And that goes up to 0.76 plus 0.06, which would be 0.82. So our answer is between those two. You can also write it as a percent, which would be between 70% and, but to 82%. It's between those 2%. So you can say in either way. You can write it as a decimal or this. So this story is saying your likelihood of your sample proportion would be between these two with this scenario. All right, so what type of study is the following? A polling agency randomly calls 2,000 people and asks them who they plan to vote for. Well, let's see, observation, survey, or experiment. Hopefully you can see this is a survey. All right, a sample is normally distributed. If the mean is 54, standard deviation is 6, then what percent of the data is between these two numbers? Shaded, label and shade the graph. So we have multiple parts to this. First thing I'm going to do is put this on here. The mean is 54, so it goes right in the middle. And then we go both sides, we add 6, and we keep adding 6 to the right. Oops, I did that wrong, that'd be a 6. Then we subtract 6 to the left, which would be a 48 and a 42. Next, it is saying that we want to be between 48, which is right here, and 66, which is right here. So we want what is between those. Between those would be all of this. All right, so that would be the label and shade. So we label and shaded it. Now what percent is that? Well, hopefully you remember that within one standard deviation both ways, that is 68%. So we do know this is, right here is 68%. And then this little piece right here is 13.5%. So if we add those two together, if we get 68 plus 13.5, we will get 81.5% of it will be between these two if it's normally distributed. The average number correct on the quiz is 16, with a standard deviation of 2.3. Kim received a 10 and Sarah received a 20. Assuming the grades form a normal distribution, who got a more common score and what was the person's z-score? All right, so let's find each person's z-score first. So we're first going to do Kim. find Kim's z-score, we take her score, minus it from the mean, which is the distance from the mean, and divide by the standard deviation. All right, the formula is right here. When we do that, we will get for her a 2.6. Next, we are going to do Sarah. So Sarah has a 20 minus the mean divided by the standard deviation. So when you, for hers, you crunch that, you get 1.7. All right. So one thing I did forget, I made a cardinal mistake. Isn't that a negative 2.6? I made that common mistake. See how it's less than 16? Don't forget those negatives. It is important. Now, it isn't really important for who is more common. The negative doesn't matter, but when we want the z-score, it does matter. So don't forget those negatives. Okay, so let's proceed. So who is more common? More common would be closer to the norm, closer to the average. The average is 0 when you talk about z-scores. So which of these is closer to 0? Sarah. Sarah is more common because she's closer to 0. So Sarah is our answer. And what is her z-score? Her z-score equals 1.7. So if I wanted what is less common, you would want Kim, because she's farther away from 0.